Right, last two speakers. Andrea Ganna comes down. I'll tell you a little bit about him. Some of you will know him. Andrea is a research fellow in Ben Neal's group in the Analytic and Translational Genetic Unit at Mass General Hospital and Harvard Medical School. He's affiliated with the Broad Institute. Andrea did his PhD in epidemiology at the Karolinska and had a fantastic paper in The Lancet where he looked at UK biobank and risk of death.
Know what I'm saying.
Fantastic. Okay. And Andrea, so he's at the Broad, but we'll be seeing a lot more of him probably. He's designing studies that will compare Finland, Sweden, Denmark, and now Mark Daly's recently, as you know, been appointed as the director of the Institute for Molecular Medicine in Finland. Then there'll be a pull factor from the Broad where bright people like Andrea will be spending time in our neighbouring Nordic country, Finland. But Andrea's going to talk a little bit about health trajectories, risk factors, experiences, and ambitions. Andrea, you have the floor. Thank you.
Hi. Thank you, John, for inviting me here. I was not aware, so you asked me to speak about disease trajectory. I was not aware I knew something about disease trajectory, so I'm trying to do some data visualization and disease trajectory and to put them together. The things I'm not going to speak about is genetics, so you can all relax a little bit. Why we need data visualization? And I think that's a very important question I'm trying to answer, and I'm going to show you some example of a large-scale visualization project that I've been involved, or some of my colleagues have been developing. And I'm going to give you a little bit of a sense for more those technically oriented how these visualization tools are done. And in the last part, I'm going to tell you a little bit about ideas on how to model disease trajectories and why those are important and why we need a data visualization tool for that. So scientific papers are getting more and more complex. You all know you have more and more supplementary table, more figures. And indeed, apparently the number of pages in a scientific paper is also increasing. So when my biomedical research is scaling up and we need tools to communicate our result, which are not about the printed paper with new methods, this is some example of research we have been doing. We've just been generated a GWAS of more than 2,000 traits in UK Biobank. We actually produce more data than what we imputed when we use for the analysis. MR-base is another large-scale high-throughput Mendelian randomization, and we will see more and more saturation genome editing, so try to CRISPR out every possible mutation in the genome and see the effect of that. So how do we report this result? How do we make it available to the public? Data visualization tool allowed this type of endeavors, and they allowed you to share really the result faster, to make them easy, and importantly, they allowed you to reach a larger scientific audience, which can be from other fields, and that can create collaboration and spread of ideas. If you are more an egoistic type of person, if you share the data and you make available, you also get more citation in your paper. So that is also an instant motivation to do that. I think there are mostly three types of data portal or website, and I'm going to walk you through. The first are those that I call short-term paper-specific portal. Those portals are really made to enhance the reader for a specific paper. And they are normally simple, but they are functional. And you want to use pre-made solution, but they are not long-lasting solution. They normally last with that paper. They don't get updated over time. We then have a long-term, what I call born-to-last portal, where really the portal is the main delivery of the project, and one portal might support different papers. I will talk about that. I've never been directly involved in this portal, but I will show you a little bit about the Nomad project. I just want to stress how important is engineering money and specialized personnel to maintain this solution. We'll finally touch upon what our communication partner, where really the deliverable is not the data per se, but rather the content and how this partner can be used to share message to the wider community. Okay, so the first example, which I'm going to show you, is this Hubble project. This is a study we did around 3 years ago on UK Biobank. What we wanted to do in this project was really to just do an association between each possible risk factor in UK Biobank and 5-year mortality. And indeed, we use all the variables that were available at that time, and we see what's the prediction for each of these variables and what's the association at 5 years mortality. At that time, there were around 655 predictors and around 8,500 deaths for a median follow-up of 5 years. So we did this study and we realized that our supplementary table were around 9,000 rows, which was not very functional. For those in genetics, this is kind of normal, but in epidemiology, you tend to produce much less data because normally you answer one research question rather than many research questions at the same time. So we wanted to come up with a website that will allow to explore the data, but also to do some more fun stuff like doing a calculator for 5-year mortality, for example. And so since I didn't want you to go outside the presentation, I'm doing just a video and I'm going to describe you what you see. So that this is the Hubble website that you can go and check it. We have mainly 2 parts, an association explorer and a risk calculator. And this association is probably really to show the result of our main analysis, and you have the results separate for men and women. And so, for example, if you click on women, you can see the result here. You have the accuracy to predict the risk. So the 5-year mortality risk is measured as C-index, is very similar to the area under the rock curves. Here is the association with age, and each of these dots is one of the risk factor, one of the 655 risk factor in UK Biobank. You see that the top predictor for women in this age range is cancer, but if you do down the list, you have other interesting association, disability, and for example, usual walking pace. If you click on each of these dots, you get the association, but you get also the odds ratio for each of the categories, so in the questionnaire as compared to the reference. Since most of these things are actually age dependent, so there's no proportional hazard model, you can actually have the results stratified by age category, and again here you can see the different association for different age groups. We try also to allow you to not only to look at all cause, but cause-specific mortality, and you can select the different categories you want to include in your analysis. Here we include almost everything that was available at that time. Here you have all the variable, and here you can link and go directly to the corresponding UK Biobank page, so you can actually see the distribution of the variable. Something that we really invest a lot of time in doing and try to make it understandable not only for scientists but also for people that were more interested in this topic in general. So more or less wherever you click, you have some kind of explanation of tooltip so that a general person can understand that. We have a kind of lay summary, we have frequently asked questions, and so on. For fun, we did also this risk calculator. So we asked, we have calculated the association, can we actually predict 5-year mortality? It turns out you can do it quite well with around 12, 13 questions. You get an AUC about 0.84. And so here, these are the questions which are specific for male and female. A lot of these things are really not modifiable risk factor. They're just like very good proxy for social economic state or other underlying comorbidity. Some of them they are actually UK specific, so it's not really clear how much this is generalizable outside the UK. We have been recalibrating the results so that they're representative on the entire UK. So we use the census and life tables so that the estimate absolute risk will be generalizable for the entire population. So when you're done with selecting all these things, you get something which your report. Here you get something called able age, which is your risk of dying in the next 5 years. This is equivalent to the average risk for men of 16 years old in the UK. And so this is a nice way to represent the concept of probability, which otherwise would be difficult. We also did this graph. So here you see the risk is 5%, so you have 5 red little men and out of 100 people. And since these risk factors were not generalizable, they were not preventable, we also allowed people to, get some kind of more information about lifestyle change and health changes by clicking on these different links. So this is, I think, an example of paper-specific portal. It's still on. We didn't update it for at least recently. I think the main take-home messages was that this measure that can be obtained by verbal interview were the strongest predictor of all-cause mortality. Remember, we have some of the things everyone is interested in, like BMI, systolic blood pressure, biological markers. They don't predict as good as a question like how do you rate your overall health. So take-home message, those things works quite well in terms of prediction. You can develop a 5-year score. We get a lot of visits at least the first days, and then naturally when the attention goes down, you don't get so much click anymore. This is my favorite media coverage by Christian Today. I'll leave it there. Okay, so let's now move to a long, born to last type of portal. This is a Nomad browser. This is really, I'm not much involved, but so I really need to acknowledge these 3 people that has been developing the portal. Something I have to just tell you is that this portal is handling something like 300 million variants. So every time you click on each of these variants, it needs to go back to the database, take up something and represent it on your portal. So there is extremely engineering behind that. And that means that you require specialized staff, software engineer with experience in data visualization. The good thing is that when these people spend a lot of time thinking about something, they normally do it in a good way, and then you can use the same concept and apply it to other scenario. And so I'm going to show you the Nomad browser and how that's being used for exome sequencing, schizophrenia exome sequencing result browser. It's the same architecture applied to different problems. So here you have the Nomad browser that's also live. You can go and click on it. This is the beta version. You can click on a gene, you get this representation. Again, here you have all the variants in this specific gene. With the corresponding allele frequency, and the different mutation and which kind of impact they have, if they are missense, loss of function, or synonymous variants. So you see this nice visualization that's happening here when you move. Now I just move. Let me pause a second. Maybe you didn't notice, but cannot pause. I just move to another browser. Let's see here. Okay, you almost don't see the difference, but actually this doesn't have any more allele frequency, only has p-value for exome sequencing analysis of schizophrenia. So this is a large project with more than 20,000 cases of schizophrenia exome sequence that controls. So you see we use exactly the same approach. You have the same type of visualization, but now what you have here is p-values and so on. And you can also, again, partition on missense, loss of function, and de novo. So these are really nice because you can use it for different approaches. Just to give you a small Easter egg, this is like one of the oldest version of Nomad, so you can see how actually things change, how this website have a life themselves that goes through time and different iteration. So how do you actually build a data visualization tool? So this is like more or less what they use in Nomad. So first you have a nice database. The choice of the database is extremely important. Elasticsearch is a kind of safe choice. Then you have some kind of interface that stands between the front end and the database, which is normally done in Python and Flask, which really query the database and give back the result on the front end. This is the most time-consuming part to design. A lot of graphics are done in D3, which is a JavaScript library. It's complicated. is not user-friendly, but that's what it delivered the most robust results. And then now we kind of do everything package up using Docker and put it on the cloud. It means that actually this website lives on the cloud, and the cloud scale depending on how many access you have to the website. So if there are a lot of people interested, the more machine gets created and more people can access to the website, which make it very flexible. If you don't have time to do all this part, or your website is smaller, you can actually use pre-made solution like RShiny or Plotly. Clearly, they are not so customizable as writing your own front end, but that's another solution. Another type of website is result communication website, where you really want to try to touch upon the main public and communicate results. So I'm involved in this analysis of GWAS of homosexual behavior, which is clearly a very sensitive topic. And so we're actually been collaborating with Sense About Science, which was also involved in the Hubble project. They helped to organize 2 workshops in London with representative LGBTQ organizations, and their feedback were used to frame this website that will be live when we post the paper. And so I just wanted to give you some take-home message when your message is to communicate to the general audience. The first thing is language, which scientists are not good with. The word like risk ratio, for example, it cannot really be used if your output is homosexual behavior. This is something to take into mind. There are a lot of other small things where the way we use the words in science sounds offensive outside our world, or they are not appropriate. The other thing is, don't try to cover everything when you do this type of portals. I think there is the sense that you want always to protect yourself from criticism, and so you fill it up with a lot of limitation, which end up like being a little message and 3 pages of limitation. I think there is a paper for that. You need to be clear and concise. And it's clearly the paper should be kind of complementary to the website, and so you really need to try to inform without being boring, and not because boring is bad in general, but because if you bore people, people don't read the website, means they don't get informed. And then I want just to stress the importance of toolkits and glossaries. Every word or a lot of words try to explain what they mean. For us, irritability has a clear meaning, but if you ask the general population what irritability is, it doesn't know. So it's important to use a lot of toolkits, which we've been using. Okay, the last thing is about disease trajectories, and the reason why I want to talk about that is because I'm also going to show you a data visualization tool about that, but it's also because this is something I hope to work in the next few years. So almost every individual gets exposed to healthcare system during lifetime, and this is really the base for epidemiological research. This is a kind of semi-real individual from Finland, get a lot of different contact, different medication over time. So you have this disease trajectory. What a lot of epidemiological research has been about is like, does acute nephritis associated with something else down the line? So one question, one answer. There's absolutely no reason why we cannot move from this one to just do it larger scale. So this is some data set that we've been working on, we're applying to get, and I just want to give you a sense of how large are these data. And a lot of people think about genetics as being the big data word, but it's really epidemiology, the big data word, because any of these registries contain more variants that are in the NOMAD database, okay? And so this, for example, just some extrapolation. This is a Stockholm County database from 2006. If you put together all the data, we have around 380 million data points. In Finland, we're now expanding FinGen on 500,000 people, but if you expand this 55,000 to the entire Finland, you will have around 528 million data points, only if you include the inpatient and drug registry. Drugs prescription claim is where most of the data really comes from. So these are big data. The thing is that a lot of these analyses, are done by, these data are normally stored on SQL database. What you do, you just extract one ICD code, another ICD code, and you just analyze. John is pushing this one a little bit more larger scale, but we can do it even more, and we can try to crunch a lot of this data together. So idea, a really long-term goal, a little bit ambitious, is really to develop a platform to report real-time and real-life information to doctor, hospital about disease medication. So there's no reason why we cannot help a doctor to summarize the information about the comorbidity history as well as the medication history of their patient, especially primary care physician when they come in their office. And we can do that by providing individual risk assessment. If we have good prediction about that, if we have good information, we don't need to provide everyone with information, or if there is a reason and a need for that. Importantly, these type of tools, which are just phenotype-based, are extremely important for large biobank AP project. We see extreme pleiotropy in the genetic space, and most of the time it's just because the two comorbidity, they always get diagnosed together. A lot of genetics thinks in case control ward and imagine that people that have that disease, they don't have anything else. But as been shown in this meeting very well, there's a lot of comorbidity. And so we need, currently it's very difficult to navigate across this phenotype space. So we can do that in a way. And so really like the idea of getting this platform at the doctor desk. We started very in a small scale using UK Biobank data because that's the easiest to get. What we did here, it was like, can we just get association between each ICD code and any previous or past ICD code to our ICD code of interest. So for example, RO7, which I think is chest pain and myocardial infarction, we want to know if there is an association between the two. To do that, you need to use something like 10-variant covariate survival analysis, because indeed you want this individual to be at risk only at this time point and not starting to be at risk here, for example. And so we've been doing that on every possible ICD code in UK Biobank, so you can explore it. We've been done a portal. We didn't even publish actually a paper about that. We just wanted to make the data out there. It is very in alpha phase, but for example, if you select something F10, which is alcohol-related disorder, you can go there, see the number of individuals in UK Biobank, prevalence, the mean age at the first event, which are the most common comorbidity. You get 5-year mortality estimates divided by male and female and age, and we will get this one personalized in the end. We have 30-day hospitalization readmission. We have distribution of risk factor for individual that have that ICD code as compared to the population. We have a map on England where you can see where these pinks are more prevalent, which is inside London, where people drink a lot, and Liverpool, so close to the urban centers. And then we have, indeed, that adds a ratio for each of the possible other ICD codes. Here, some are very high, as you can imagine, because some of these ICD codes are basically always given when you get the other ICD code. You can do it long term, so having, or short term, you're allowed only to be 6 months before or after. Okay, so this is another approach. I mentioned we are hiring for people working on this project, so please let me know if anyone is interested. We are going to expand that project using possibly the entire nationwide registries and some of the Swedish data, and so it will be interesting to see what we can do. Something about challenges. The first one is privacy and security, which is very tied with the enormous computational burden to calculate these things. People maybe realize that some of the epidemiological analysis we can do it on, Statistic Denmark computer. This analysis cannot be done there. We need cloud computing, and it's kind of something that we need to go there. There's no way to escape for that. It's not that making the local cluster bigger will solve the problem. So just something to be aware. Clearly, this just there's a lot of confounder. Avoid causal claim. There's diagnostic bias, but we are working on that to try to really get hard definition that are validated for some of these outcomes. So some take-home messages about this entire data visualization business. I think there is a temptation to do the website because you want to be cool, because you think your paper will be nice to have a website. I think you should really think about that to be useful and enhance the content of the paper. It needs something that people use and people think as added value to the paper. Currently, there is no clear value how much these efforts are valorized in publication grant system, which I think is a major limitation. Paper, at least my experience, seems don't care. You have a website, you don't have a website, great. And so do we really want to spend maybe 6 months doing analysis and 6 months to create a website if you don't have any value? And there is, can you get a grant if your only deliverable is a portal? So this is some open question. For example, I know the Nomad portal didn't get funded through more like not NIH sources. So that's something to think about. If you want to do a really long-term portal, you need to invest money and have trained personnel. Postdoc goes away, unfortunately, PhD student as well. So you need software engineer that stay there. You need to pay them well. And frame your web portal with your goal in mind. And again, don't reinvent the wheel. There is a lot of pre-made stuff. There's no need to reinvent everything from scratch. Okay, thank you.
I actually didn't introduce you properly. We asked Andrea to talk about data visualization because he's been a great inspiration to Jan and Oliver and I. And you'll see that he's really been leading the way in democratizing the data, so pushing it out, making the huge data able to be interrogated. We've got a little bit of time for questions, so Peter.
I have a question about your online phenotypic predictor of death.
Mm-hmm.
It looks at the first glance a bit like the genetic of the phenotypic equivalent of 23andMe, that it's personalized in a way. So don't you have any issue with that the FDA might think this is a medical device?
No, we didn't get that criticism. We got some hospital that wanted to implement it, but mostly assurance company were extremely interested about the effort. No, we never get any regulator on saying anything. The assurance company, which I didn't realize, they're really interested because they don't want to ask people if they smoke. They want to ask questions that point at smoking, but it's not about smoking because people lies. I think there is a survey that think that 70% of people think it's fine to lie at an assurance company if they smoke or not. So they're really interested in a lot of our predictor are kind of mysterious, like walking pace, which is like a good proxy for comorbidity without asking if you're sick or whatever. So they were interested on that side.
Yeah, go Peter.
So follow on from that line. So the insurance company could ask the questions you're asking without them lying and adjust the premium. So are you doing people a favor or not?
Well, it turns out, I don't know in Australia, though I remember I had some contact with someone in Australia. In England, unfortunately, apparently there is a regulator of question of assurance. So it turns out they cannot ask things that people don't understand why they've been asked. Yeah. So it's messy, but yeah.
These are great questions. I mean, the ethical and governance framework, and the other thing, Andrea, is that you haven't updated it and a lot more people have died. So it could well be some of your estimates will need to be revised. So
yeah. I mean,
your site has a use by date because the data are now don't reflect how many people have died.
Yeah. We can extend a 10-year follow-up if we want, and that would be even more interesting, I think.
Okay, this is the type of discussion we're having for many years. Andrea, thank you very much.